So I'm here at Microsanj, and I want to show you something really different in terms of how thermal imaging is done. So this is done based on thermal reflectance, which is a physical property of material. That means that depending on the temperature, surface temperature of a material, the amount of light reflected back from the surface of the material is going to be different. It means that you can draw a correlation between the temperature, surface temperature of whatever you're looking at, and how much light is reflected back off of it when you shine something on it. So here you can see green light shining directly on top of the surface of a MMIC module. Now, why is this such a good idea and such a revolutionary idea? Because it allows you for several things. You don't need a thermal imaging system that is designed to operate at several micrometers. You are operating in visible light, which means all of your microscope devices and components are operating in visible light. You can see right through them as you would normally do with any microscope. So what they do on top of that is that they correlate the shining of this light with a lock-in amplifier that they have designed connected to a camera up here, and everything here is synchronized together. And this allows you to be able to do frames as small as a nanosecond. So you can capture rates so high that you can see the flow of heat due to the flow of electrons in a MMIC with the resolution you would expect to see from an optical instrument, which is absolutely crazy. So here's an example of that. You can see here directly under the microscope, we are looking at a picture of the MMIC, and here we are seeing the thermal image at the resolution of the optics, and you can capture this at sub 1 nanosecond rates and actually see the flow of electrons and the flow of heat through the system. And this is going to be incredible. Of course, there's a lot of things in the background that needs to be done that they have done in advance. They need to calibrate this whole system, but this is all done. So all you have to do is just point it at what you want to look and then measure. And this thing has a sensitivity of a few millikelvins, which is itself is pretty incredible. So you can see tiny changes in the temperature. So for MMIC design and for next generation ICs where you want to see how your power amplifiers are behaving, exactly what is the thermal profile of something, you can just look at it under the microscope and get a thermal profile. A really interesting technology from Microsanj, which I hope that you would check out.